Hello, welcome everyone and welcome back to my channel. In physics, we have already done the equations of motion, Newton's laws of motion, and today we are doing questions on equations of motion. These are very important. So just a quick revision, we know we have three equations of motion, which is V is equals to U plus AT, V squared is equals to U squared plus 2AS, and S is equals to UT plus half AT squared. And also we know these notations, that is V is final velocity, U is initial velocity, S is displacement, T is time, and A is acceleration. Now let me do these questions and we have to see that how can we apply these equations of motion to solve these questions. Question 1 says, a car accelerates from rest and attains a velocity of 30 meters per second. Find its acceleration after 20 seconds. See, if it says that a car is accelerating, that means obviously A is somewhere and that we have to calculate. So whenever you are doing questions on equations of motion and any sort of numerical that you are doing, the first thing is you have to write down the data which is given and also the data that they are asking you to calculate. In this case, they have given that it started from rest. Keep that in mind, starting from the rest, that means your initial velocity is 0. That's the meaning of rest. Then final velocity, that means V, and which it has attained, that is 30. And its acceleration we have to calculate, so I have to question mark A, and after T, that is 20. Now it helps us in finding which equation of motion. Clearly, that equation of motion that has all these parameters is your first equation of motion, that is V is equals to U plus AT. Final velocity is 30, initial is 0, A we have to calculate, it's 20. So A is 1.5 meter per second squared. In this question, generally in GCSE question, they have given the unit in many cases, and if they haven't, then specifically they write it in one marker that what would be the unit, so you should know it. Question 2 says a ball is thrown upwards with an initial velocity of 30 meters per second. Calculate the maximum height it reaches. See, now what's given, that initial velocity U is given as 30, and when you are throwing something upward, when it reaches to its maximum height, at that point of time there will be 0 velocity. That means finally at that point it will attain a velocity of 0. That means your V will be 0. Now acceleration, G will be your acceleration because G is called gravity or acceleration due to gravity. This is actually an acceleration gained by something when it's under the influence of gravity. So and it has a fixed value which is 9.8, and it's important to use the sign convention because acceleration is a vector quantity. So if something is falling down, we'll take plus G, and if something is moving upwards, in that case we are taking it negative because it's working against. So here I'll be taking G as negative 9.8. Now obviously what they are asking, S they are asking. So if I pick S is equals to UT plus half AT squared, that has time, and we don't have any time here, so obviously we are going for third one because first one doesn't have S in it. Out of these two, the third one is the most appropriate one, which is V squared is equals to U squared plus 2AS, and in this case 2GS. V is 0, this is 30 squared minus 2 times 9.8 times S. Now bring it to here, that will give me minus 900 equals minus 19.6 S, and finally S will be divide 900 by 19.6 will give me 45.91 meters. That would be the maximum height it will attain or it will reach. Question 3 says a cyclist accelerates uniformly from 0 to 10 meters per second in 6 seconds. Find the distance traveled. Distance, again I'll be saying out of 3, 2 have two equations are there where we can find s, that is your displacement or distance, and which is the second one, that is s is equals to ut plus half at squared and v squared is equals to u squared plus 2as. The third one doesn't have any t in it, so we will be using s is equals to ut plus half at squared. Now the cyclist accelerates uniformly from 0, that means initial velocity is 0, 0 times t is 0, and acceleration they haven't mentioned, they have just mentioned that initial and final velocity, so it's easy, we can easily calculate acceleration. So half times a times t squared, which is 6 squared. Now we have to calculate acceleration. Acceleration is change in velocity over time. Change in velocity is 10 minus 0 over 6. So 10 over 6 is the acceleration. Substitute it here. You'll get half times 10 times 10 over 6 squared. That will give me 30. So s is equals to 30 meters. So that will be the distance traveled in this time period. A car is moving at a velocity of 20 meters per second and the driver sees an obstacle and brakes, producing a uniform deceleration of 4 meters per second squared. How long does it take the car to stop? See, so basically there is a car which is moving with an initial velocity of 20 meters per second and driver sees an obstacle and brakes. That means finally he has applied the brake and car will stop eventually. That means which makes its final velocity 0. It produces a uniform deceleration. Deceleration, that means when it's deaccelerating at every second, when it's reducing its velocity every second. And by a constant deceleration, that means every second this car is decreasing its velocity by 4 meters per second. So that's the acceleration. So I would be saying a is equals to 4. How long does it take to stop the car? They're asking the time, so it will be v is equals to u plus at. Obviously that would be the only I can say the acceptable one in this case. So this will be 0 and this is 20. I told you acceleration is a vector quantity, so in which direction is it moving is important. We are reducing the acceleration, that makes it negative. So negative 4 times t, so 4t is equals to 20. That means after 5 seconds it will eventually stop. Now it says how far does it travel before stopping. So we have the time, so we can use s is equals to ut plus half at squared. So s is equals to ut plus half at squared. Even the third one can also give you the answer. So its initial velocity is 20, time is 5 plus half at squared, because it's deaccelerating obviously, so we are taking negative. So that means minus half times acceleration is 4 and time is 5 squared. So that is 100 minus, that will give me 50, which is 50 meters. So it will stop 50 meters before stopping. Now the last question, it says a train accelerates uniformly from rest to 100 meters per second for 60 seconds to reach its destination. It then travels at this constant speed for 60 seconds before deaccelerating uniformly to rest in 40 seconds. Draw a velocity time graph for the motion. So that means this is our graph. Obviously it's a velocity time graph, so I'm just making it v and t. It says a train accelerates uniformly from rest to 100 meters per second for 60 seconds. That means for 60 seconds, till here 60 seconds, it keeps on increasing constantly like this. And then it says to reach its destination, then travels at constant speed for 60 seconds. So the next 60 seconds it will move with a constant speed. So this straight line represents the constant speed, so that would be 120. And finally deaccelerating uniformly to rest at finally in 40 seconds, so it would be like this. So it would give me 160. Now it says that you have to draw the velocity time graph for the motion that we have drawn. Now calculate the total distance traveled by the train. So it would be, for the total distance, it has to be the area under curve. So for that, at least we should know the height. So it's what mentioned that train accelerates uniformly from rest to 100 meters per second. That means this is 0, 0, and this point, let be y. This y value is also mentioned here, that from rest to 100 meters per second it reached. So this is 60, and this is already given that 100 meters per second, so that's 100. Obviously here also it will remain 100, and this is 120. We have to find the area of this trapezium, so half times sum of the parallel sides. So this distance is 60 and this whole distance is 160, so 60 plus 160 times height, which is 100 in this case. So that will give me 160 plus 60 is 220. So 220 by 2 is 110. So meters, or 11 kilometers. That's the answer. Calculate the average speed of the train, that means total distance by total time taken. So total distance was 11000 we have calculated, and total time is 160. That's in seconds. So finally we just need to divide them and get the answer. So this is 68.75 meters per second. As unit is not mentioned, so we can keep it in meters per second. So that's it for today. These were the simple questions, but were very they're very important to understand. And also in the next class we will be doing the rest of the forces and motion, and also we will be doing the past paper questions as well on AQ and Edexcel both. So and also if you're looking for one-on-one live online classes for GCSEs for any subject, the classes are starting at just £6 per hour. Like, this is very minimal cost, I would say. And also if you're looking for classes for any year and any subject, all you need to do is just email us at exactacademy@gmail.com and we'll coordinate. And if you're looking for these free worksheets and free theory sheets, they are available at exactacademy.com. So that's it for today. Bye everyone, take care.